So key topics first I'll discuss what is embedded system. So I hope everybody know what is embedded system. So if you can give your thought what is embedded system, it will be nice for me so that you are in I and we are in same page. So any idea what is embedded system? Let's make it little interactive. What you know about embedded system? Either it's a hardware or is this software or what is this? So any idea?
Professors, you can drop it in the chat box. Drop the answers that you think is right in the chat box.
Yeah, software embedded into hardware. It's correct. Yeah, it's hardware plus software. Again, it's correct. Yeah, so I think almost everybody knew this is combination of both, combination of both. Yeah, cool. So this is the actually correct answer. So I'll just describe because I saw many are from also from different background. So they don't know how it is combination of software plus hardware. So I'll start with one good example. How to kill a mosquito. So if you'll see a mosquito, how to kill it without using mosquito coil or mosquito liquid. What is the process or what is the step-by-step process how to kill any mosquito? So I'm going to tell what is the process. So basically, generally we follow. You are a means we are a human being. So what we'll see, we have eyes. So through that eye, what we will do, we'll sense it first. What is the first step? First, we are doing sensing. So because we are a human being and we knew what is mosquito, what is other things, we by sensing we can get it. So what the first process is sensing. Once sensing is done, what is the next process? Suppose we'll see that mosquito is there and it is there on the top of the fan, so we cannot go and kill it, right? We cannot go there. So in that time what we'll do, we'll wait, we'll plan, right? We'll plan when this mosquito will come to our place, then only I'm going to kill it. So that is the next step we are going to follow. So what we are doing, we are doing some planning. And finally, once the mosquito will come to your place, then we are going to kill it. So that process is called executions. That process is called execution. So you are a human being, you are eating food, drinking water, you have eyes, you have brain. So you are doing all these things. Now, same process we'll see. Think about any machine. Think about any machine, what is there so that the machine also doing same thing. I'll give a small example. Whenever you are going to any shopping mall, automatically the door is opening. How it is possible? Because there is a sensor in front of the door which will sense, and finally there is a motor which will rotate the door so that you can go inside. So if we'll talk about that, any machines, what is there in the sensing part? We can see some input devices. We can see some input devices. It may be any switch, I can say. It may be, we can say sensors. So there are some input devices are there. By using that, we generally sense. Then, what is the next step? Planning. Who is doing planning? We are the human being. Whatever plan we'll do, according to that, it will execute. Suppose I'll give a small example. Suppose I'll write one small program, integer a comma b. I'll write integer sum. Then sum equal to a plus b. So if I'll write this program, then this program will give summation of two numbers. So however we'll plan, however we'll write the program, according to that, the machine will behave. So we are planning something here. Then finally, who is executing? What is there inside the machine so that it will execute? So there is a processor or controller. There is a processor or we can say controller which will execute all the things. Apart from this also, with the help of some output devices, it will execute. Output devices like I can say LCD, we can say this motor. So these are the devices by using that machine will execute. Now, if you'll see this system, one more very important thing is there. Without that, your machine will not work. What is that? Suppose you are using mobile phone. Without power supply, without battery, will your mobile phone work? You cannot use it. If a battery is dead, you cannot use your mobile phone, right? So for every machines for every system's power supply required. So we need require some power supply. So this power supply we are giving where? We are giving to our sensing part. We are giving to our execution part. And finally, this complete system, we can consider that either we can say automation system, also we can say embedded system. This complete system, we can say automation system, or we can say embedded system. This is the first point. Either we can say automation system or embedded system. Now we'll see then what is there in this system. If you'll see here, there are some hardware devices we are using. We are using some hardware devices. These are hardware devices. Also, if you see here, we are using some software component. We are using some software component. And finally, also, if you see here, we are using some hardware devices. Here also, we are seeing we are using some hardware devices. If you see, we are using hardware, along with also we are using software. Now, the complete system, in that complete system, you have hardware, also you have software. It's a very simple thing. What you told from the starting. It's nothing, it's a system which is a combination of both hardware and software, which is a combination of both hardware plus software, and which is designed to perform some specific task, which is designed to perform some specific task, right? So embedded system is nothing but it's the combination of both. It's combination of hardware and software which is designed to perform some specific task. I'll give a small example. You are using smartwatch. If we'll see in a smartwatch, right, there are some screens there. That is the hardware part. There are some sensors are present. That is hardware. Some microcontrollers present. That is hardware. Along with to run the smartwatch, you are writing some applications. You are writing some codes. That is nothing but your software. So it is the combination of both hardware and software. So I think you told same thing. So it's a combination. Yeah, software code is stored in program memory. Yeah, that will come after some time. This is a very basic. I told what is embedded system. So memory concept will come because the memory part is present inside the processor or controller. So yeah, so this is basically combination of both hardware and software, which is designed to perform some specific task. So this is about embedded system. I hope everyone clear with this. So what is, if you see this diagram also, these are the things present in hardware, peripherals, sensors, actuators, and these are the softwares we have. Also, these things I'll explain also in RTOS, real time uh, means your OS concept. So whenever we'll touch OS concept tomorrow, that time also we'll understand it perfectly. So now, next, very simple thing. If you got to know that what is embedded system. Now, next question is why I learn it? What is the purpose? Very simple idea. You got to know that it's deal with hardware, it deals with software. Once you will become one, once you will become an embedded system, means once you learn embedded system, then if you are going to find any job opportunities in the industry also, there are two kinds of job you will get. One is embedded hardware engineer, one more is embedded software engineer.
Uh,
So
Sorry to
yes.
disturb you, sir. Sir, can you make it full screen? Can you make it in presentation mode? And I believe somebody has asked to explain that part again, the previous one.
uh, Previous one is this one.
Preeti ma'am, are we looking at this one to be explained again? Next slide. Next slide.
Okay, I'll go to next slide. Okay, fine.
Yes.
So
So full screen again.
yeah,
To
yeah. So we are talking about embedded system. So if you'll see here, embedded system. So as I told, this is a combination of both, where we'll see hardware and where we'll see softwares. In case of hardware, these are the things present: peripherals, sensor, actuators. All the devices are present in hardware, and all the devices are present in software. So why I did not go much, because again I'm going to explain all these things properly, so that I just gave one demo here that, okay, this is about embedded system where we have some software and where also we have hardware. Again, this part also I'm going to cover in the next slide. So embedded system, where it is used, in which place it is used. So that also we are going to discuss in the next slide. So yeah, so then the next is, suppose you know about embedded system, then what is the, what you are going to become as a general things. So there are two kind of engineers are present in the embedded system world. One is embedded hardware engineer, one more is embedded software engineer. Embedded hardware engineer means they're only dealings with hardware. Simple. What is that dealings with hardware? Maybe they are making some microcontroller, or they are making some chips, or they are making designing some part in the vehicles, or maybe they are designing some part in the smartwatch. It may be anything related to hardware. And who is embedded software engineer? They knew the hardware, also they knew the software. Who is going to give the life to that hardware? Who is going to give the life to that hardware? So they are coming under embedded software engineer. So there are two kind of engineers generally deals. One is hardware, one is embedded software. So basically, who is going to become embedded software engineer? They should know both. Without knowing the microcontroller, without knowing the sensors, you cannot write the code. So for that, you should know the both the things. So then we'll discuss about scope of embedded system. Why this is important nowadays in the industry. Why people are talking that, okay, embedded system is so much demand now in the industry. If we'll talk about this domain, we'll start one by one. So how it is affecting to this domain. We'll talk about very well-known domain nowadays. Nowadays, everybody are telling automotive domain. Everybody are talking about electric vehicle. Everybody talking about electric scooty. What is that? This domain is called automotive domain. Automotive domain means it is dealing with vehicles. It is dealing with vehicles. It may be passenger vehicle or it may be commercial vehicle. Passenger vehicle means your car, whatever bus, or commercial vehicle means trucks, whatever where goods generally will carry. So now if we'll see how much it is booming. So today, if you'll see in the industry, Tata is releasing one car. If you consider Tata Sierra, right? Again, tomorrow you'll see Volkswagen is releasing a new version of car. Again, next day you are seeing Maruti is releasing a new version of car. Every day you are seeing a new version of car. Do you think that only they are changing the design? Not exactly. They're also changing the features, right? If you see in the new technology car, so many features they have implemented, like cruise control, adaptive cruise control, blind detections, ABS, airbag, so many advanced features they are implementing. And what is that? This is part of embedded system. This is part of embedded system. And one more thing also I wanted to tell, if you'll see today about the electric vehicles, your electric scooters, electric vehicles, where you are dealing with battery, you are dealing with chargers, you are dealing with so many softwares also inside that. So everything coming under automotive domain. Do you think that tomorrow people are going to stop using it? No. Every day new versions of car coming, new versions of vehicles coming, and people are buying. So this is about automotive domain. So this is a very good scope in this domain. Now we'll talk about next domain, that is aerospace domain. And what is aerospace domain? And one more thing. Also, I want to highlight about this automotive domain. So there are very key players are there in the industry who all are working for automotive. Like there is a company called Qualcomm. There is a company called Mercedes, there is a company called BMW, all the OEMs, all the car OEMs, all the car manufacturer company as part of automotive. Apart from that, also there are so many companies who all are making the products like Bosch, Continental, Aptiv. So there are so many companies that are involving with automotive. Okay, you can take one example of very good example of Ola Electric. So there are also so many Indian companies are there, Indian startups are there. They're also working in this domain. Next domain, I was telling about aerospace domain. So what is aerospace domain? Aerospace domain means it is dealing with aeroplanes. It is dealing with flights. you must have heard about Boeing engines. You must have heard about Airbus engines. So these are coming under aerospace domain. And if you see aerospace, inside aeroplane, whatever the infotainment system is there, along with whatever you are talking about the autopilot mode, all these are part of embedded system. Your satellite, your radar system, everything. You can not only connect the sensors. Now that sensor, how it will work, you need to write the code. So all these are about embedded system. And do you think that people are going to stop using aeroplane tomorrow? No. This is also one more feature, one more scope in this. And one more domain is consumer electronics, which is very famous domain. Consumer electronics means what? Whatever things you are using in your day-to-day life. You are using a refrigerator, you are using washing machine, you are using televisions in day-to-day life, whatever you are using. Apart from that, also you are using mobile phone, you are using smartwatches, so many devices. All these are coming under consumer electronics. If you'll see also the competitions, right? So today, Samsung is making one refrigerator with new features. Tomorrow, LG also telling, I am also there to match your features. Tomorrow, higher is there. They're telling we are also there to match your features. Same way in the mobile phone sector also. Today they are releasing one mobile phone, and tomorrow they are releasing one more mobile phone. So now think about this domain, how much consumer electronics products are coming into market. And there are so many companies. If we talk about that, Samsung is there, LG is there, Toshiba is there, all the wearable devices, all the household things, so many companies, they are working for this consumer electronics domain. And again, my same questions, do you think that people are going to stop using this tomorrow? No, because this is the demand in this domain. Next, I'll go to one more domain, that is medical domain. I'll go to one more domain, that is your medical domain. So what is there in the medical domain? So nowadays you are seeing robotic surgery. Nowadays you are seeing the latest version of equipments are there, which we are using to measure the our body parameters. So every day you are seeing a new product in the medical industry also. Though that is also booming in this medical domain. So all these are part of also embedded system. Now we'll talk about one more domain, that is gaming domain. Nowadays, if you'll see youngsters, all the young kids, what they're doing, they're playing games. They're playing games by using AR, by using VR. They're doing all these things. And in that area also, there are so many evolutions is happening. We'll talk about then about your robot and drones. So all these are one application of embedded system. So all these are also one application of embedded system. Nowadays, so many robots, so many drones they are implementing. Okay. So all these are also one part of embedded system application. So there also you will see lot of scope is there. And finally, I want to discuss one more domain, that is semiconductor domain. That is semiconductor domain. This is the domain. This is the domain. What? This is the domain. If you see semiconductor domain, whatever things you are seeing, either automotive domain, either aerospace domain, either consumer electronics domain, or gaming domain, or medical domain, or whatever things I told, everywhere we are using semiconductor. Everywhere you are using microprocessor or microcontroller. So mostly we are using microcontroller. So these are part of semiconductor domain. There are so many companies like NXP Semiconductor, Intel, Qualcomm, your Infineon, your STM Microelectronics. There are so many companies are there who are manufacturing the semiconductor, who are manufacturing the chip. That is nothing but your microcontroller. So every domain, wherever all the domains you are seeing here, all the domain you are seeing here. So every domain now using semiconductor. So this is the scope. If you see, this is the scope in this domain. So because this is the domain where we'll see lot of scope, because how we are using a newer devices in your life, same way embedded system is growing according to that. So this is about the scope. I hope everybody understood what is the scope of embedded system. I hope it is clear to everyone. Yeah. Kindly give some information about embedded system in cloud computing and IoT. I'll come there. So you are telling cloud computing and IoT.
So there's another question on why it's called embedded.
We'll come to there. Don't worry. I'll come to that. So just do one thing. Just collect the questions. One shot I'll explain. If I'll explain one by one question, then I think we cannot finish.
Sure, sir.
Okay?
Sure.
Yeah. So now, so why I gave these informations? Why I gave these informations that what is the scope of embedded system? Because you should get some interest. Okay, this much scope is there. So you should also should get to know. Okay. So now coming back to our topic. 1 minute. Okay, coming back to our topic. So I hope everybody understood about the scope. Now coming back to our topic, what is the main, okay, what is there in embedded system architectures? Now we'll discuss about embedded system architecture. So I'm not using slides much now, because if I use slides, maybe you will feel bored. So what is embedded system architectures? Yeah. So now you got to know that embedded system is nothing but it's a combination of both hardware and software. Okay. So software part will go later. I'm not covering to software part now, and we'll go about embedded system. What is there in the hardware part? As we saw, the main device in embedded system is controlling part. Okay. The main device is in controlling part, and inside that we'll see the architecture. So so basically, can anyone tell me what is controller or what is processor? What is microprocessor or what is microcontroller? Because in embedded system, if you'll see, the main part is here. We are seeing that the controlling part, the controlling part. What is that? So for controlling part, we have either you are using microprocessor or we are using microcontroller or you are using microcontroller. So what is microprocessor or what is microcontroller? Any idea? Okay, so both are same or both are different? So both are same or both are different? Okay, both are different. Yes. Fine. So the first in embedded system architecture, the first part is either we can talk about microprocessor or microcontroller. Then what is that? What is microprocessor or what is microcontroller? Either both are same or both are different. So we'll see a very small difference here. So this is my microprocessor and this is my microcontroller. Okay. So this is my microprocessor and this is my microcontroller. So both the devices are doing the same thing. Both the devices will take our informations and they will execute it. Microprocessor will take the informations and they will execute it. But what is the difference? What is the difference? Microprocessor don't have anything. Okay. Microprocessor don't have anything. Suppose you are writing one program and that program you need to put in one memory. That program you need to put in one memory. So microprocessor don't have any memory. So they are connecting externally RAM, ROM. They are connecting some external memory, that is RAM and ROM. So they are connecting external memory. Apart from that, suppose tomorrow we are going to use some timer operations, and next day you are going to use some sensor interface. So for that, for timer, they don't have any timer module. You need to connect externally timer module. They don't have ADC module to use sensors. You need to connect externally ADC module. So these are one features. These are one module which is not present inside the microprocessor, which is not present inside the microcontroller. Sorry, microprocessors. We need to connect externally. So this is about microprocessor. So microprocessor will process the things, but they don't have anything inside that. And what is microcontroller? Microcontroller have everything. Microcontroller have everything. If you're talking about memory, it have RAM, it have ROM inside that. It have all the modules like timer, ADC, whatever things we are discussing here. So all the modules are present inside that. So we will talk about RAM, we'll talk about ROM, then we'll talk about timer, all these things. Everything is present inside that. Okay. So this is about microprocessor and this is about microcontroller. So that means microprocessor don't have anything. We need to connect externally. For that reason, this is called, this is a system. This is a system. This is a whole system. And in that whole system, this is a single chip. This is a single chip. For that reason, this is called chip on system. For that reason, this is called chip on system. And what is that? The complete system is there inside a single chip. The complete system inside there in a single chip. This is called system on chip. This is called system on chip. That is called SoC. So for that reason, your embedded engineers also are known as SoC engineers. Okay, because in embedded we generally use microcontroller. Why? Because this device is small and inside that everything is there. Now suppose you are making a smartwatch. Now suppose you are making a smartwatch. Now, do you think that you are going to connect microprocessor? If you will connect your microprocessor, then your smartwatch will become wall watch. It will become big. For that reason, for embedded application, we generally use microcontroller. We generally use microcontroller. So this is the difference between microprocessor and microcontroller. So generally for embedded applications, we use microcontrollers. I'll give an example where microprocessor is used, where microcontroller is used. Suppose you are going to buy any laptop. Suppose you are going to buy any CPU. So what you are doing, according to your choice, you are telling, I want 4 GB RAM. So that you connect 4 GB RAM in the CPU. You want 1 TB memory, so that they are connecting 1 TB memory. Because that is there, we are using microprocessors. For that reason, however you want to connect externally, you can connect. Now think about any microcontroller which is used in the mobile phone. Now suppose you are buying one mobile phone. That mobile phone of 6 GB RAM, 256 GB ROM. Now, can you, if you tell to the shop, if you tell in the shop that, okay, same mobile, can you increase my RAM? They will tell no, because inside that you are using microcontroller and it is already fixed. We cannot increase it. If you want, you go to the next version where we have more memory, because there you are using microcontroller and all the devices are present inside that. So this is the first part. This is the first part in embedded system architecture. The second part is your memory. You are talking about, somebody was talking about memory. So in memory, generally, if you will tell memory, two things we generally come to mind. One is RAM, one more is ROM. Can you tell me what is the difference between RAM and ROM? What is the difference between RAM and ROM? I'll just give a small examples. I'll just I'll just ask one small questions. Okay, ROM is non-volatile, read-only memory access locations. Yes, fine. Now suppose I'll write one code. Now what I'll do, I'll write one code. This is my code. This is my code. And this code I want to put inside my microcontroller. I want to put inside my microcontroller. Okay, now tell me, whenever I'll put this code in my microcontroller, whenever I'll flash it, whenever I'll put it in a microcontroller, where it will store? Will it store in RAM or will it store in ROM? Any idea? Where it will store? Will it store in RAM or will it store in ROM? Anyone? I'm seeing answer, different answer. I'm seeing RAM, ROM, RAM, ROM. So it's very clear. You are only telling. This is what? RAM is volatile. ROM is non-volatile, right? Now tell me, if we'll put the program in RAM, which is volatile. Now suppose you have a mobile phone, right? Now in your mobile phone, they will put the software into RAM. Suppose your mobile phone will get switched off. What will happen? Your program will vanish, right? Then how will you use next time? How you are going to use next time? If you are telling that your program you are going to put in RAM, then when your mobile will get switched off, that time it will go vanish. So you cannot use next time, right? So whenever you are writing any program and whenever you are putting into the microcontroller, always remember it will store in ROM. It will store in ROM. Okay? It will store in ROM. Next point. So now, whenever now it will store in RAM. It's very clear that it will store in RAM. Simple example I'll give. Suppose you are using mobile phone. You are installing your Instagram. You are installing your Gmail. You are installing any applications. It will install in ROM. Remember, it will install in ROM. Because for that reason, you have so many memory, right? Your mobile phone have 6 GB RAM. If you are installing 100 application in 6 GB RAM, your RAM will get full. So also, if you are installing in RAM, whenever your mobile will get switched off, your all application will will vanish, right? It is not happening because whenever you will install, you'll put it will store in ROM. And whenever you are going to execute it, whenever you are going to open it, right? Whenever you are running the program, or whenever you are opening the Instagram, or whenever you are opening any applications, that time, what will happen? The program will execute. That time it will execute in RAM. That time it will execute in RAM. Your execution will happen RAM. For that reason, if you'll see, sometimes your mobile phone will get hanged. Why? Suppose your mobile phone have 4 GB RAM. Suppose here, I just want to explain here again. Suppose you want to, suppose your mobile phone have 4 GB RAM. Now you are what you are doing? You are using your mobile phone. Suppose you open your Instagram. So for Instagram, it is taking 1 GB. Again, you open one more app, that is MS Word. For that, it is taking 1 GB. Again, you are opening one more app, that is suppose game. Any game you are playing, it is taking 1 GB. And you are opening one more app at the same time. You are opening one more app at same time, there also it is taking 1 GB. So now your size is 4 GB, right? Your RAM size is 4 GB. Now, whenever your mobile phone, you are using your mobile phone with multiple applications, now what will happen? It is taking 1 GB and finally it is getting full. Now your mobile phone will get hanged. Your mobile phone will get hanged. Clear? So this is the concept of RAM. So RAM and ROM both are different. So basically in your embedded system, this is also key features. What apart from your microcontroller? Apart from microcontroller, this is also a key feature. And what is the next key features? What is the next key feature? The next key feature is input-output interfaces. Whatever input-output interface you are doing. Okay. The next feature is input-output interface. Input and output interface. And the next one is power supply. So power supply I'm not going to discuss. So these are the main key factor in a embedded system architectures. Can we do one small exercise if you are okay? Can you do one small exercise? When I talked about RAM, ROM, all these things, Can you do one small exercise in embedded C essentials, where how RAM, where also whenever we are storing the devices, how it will do it? Sorry, like when we save it, otherwise it's in RAM. I did not get your questions. Like when we save it, it will save in RAM, otherwise it will save in RAM. So again, very simple thing. You can save in RAM, but the problem what will happen, it will get vanished. It's like a temporary memory. It's not a permanent memory. Okay. But I'll do one small questions. We'll do one very small questions. Okay. It is related to embedded C. Maybe some people don't know about embedded C, or you know about embedded C, that is also well. So we'll just do one small exercise here, so that how also memory is divided into different parts, that we'll discuss here. I'll I hope anyway for embedded system we generally use embedded C programming, so that I'll just give a small program. I have a variable integer a. I have a variable integer b equal to 0, b equal to 10. Then void main. I have a different kind of variables are there. Integer c, static integer d, static integer e equal to 10. Okay. So this is a small, I'm not doing anything. I'm not doing anything in this. I just wanted to know if I'll write the small program, because in embedded system, it is very important to know if you're writing the programs where it will store. Otherwise, there is a problem in memory crash. There is a problem in memory things, which you cannot find out in debugging. So I just want to know if I'll write this program in my RAM, whenever it will execute, where A will store, where B will store, where C will store, where D will store, where E will store. Exactly. Program will store in RAM, but whenever it will execute, it will do in RAM. Now my question is, whenever I'm executing the program, where A will be there, where B will take the memory, where C will be there, where D will be there, where E will be there. Any idea? This is coming as part of embedded C essential. So whenever it is required, I'll just mix it, so that I'll not go to again repeat there. Okay. I'll come to there. So that is a concept. There is a memory concept here. What is E? I did not get. B and E in ROM. Again, I just want to clarify my point. I'm executing my program. Now I'm executing my program. Whenever I'm executing my program, of course, it will execute in RAM. So there is no question in ROM. Whenever I'm executing, always it will execute in RAM. So there is no question in ROM. So where it will store. Okay, I'll come to you. Maybe if I'm wrong, you can rectify me there. So so this is my RAM. So whenever we'll talk about RAM, because why RAM is important, it is used mainly in case of execution. So we have five kind of, this is my RAM. So this is my RAM. So your RAM is divided into five segment. One is stack segment. One is stack segment. One more is heap segment. One more is BSS segment. One more is data segment. And one more is text segment. So this is our exactly RAM. If you search in Google also, memory classification in C, if you search, you will get these 5 segments. Okay. So here stack is nothing but, okay. Before going to that, I just wanted to check. What I have defined A and B. Is this which kind of variable? These are global variable. Why global variable? Because this is outside of the functions. So consider this is a function, this is the outside of the function, these are global variables. This is which kind of variable? This is local variable. This is called auto variables. Okay. And this is which kind of variable? These are called static variable. So again, different kind of variables we have in C. We have auto variable, we have static variable, we have global variable, we have register variable. Now my question here, now I have defined this program. Now I have written in this program. So remember, whenever this memory concept will come, now in stack, what will store? In stack will store all the local variables, all the auto variables. Will store all the auto or local variables. Next, what will store in heap segment? In heap segment, will store all the dynamically allocated memory, all the dynamically allocated memory. What memory you are constructing by using malloc or calloc. Next, in the BSS segment, we'll store all the global and static variable. Or in BSS segment, we'll store all the global and static variable which is not initialized. Which is not initialized. That means which is not initialized. You can see integer A, integer D. This is not initialized. And in data segment, we'll store all the initialized global and static variable. Initialized, global, and static variable. And finally, in the text segment, we'll store all the function name, instructions, all these things. Function name, instruction, all these things. If you want, I'll share the document also. You can go through it. So now here's very simple. This A is a global variable which is not initialized. Now A will store in BSS segment. Now B will store in where? Now B will store in data segment. C is a local variable or auto variable. It will store in the stack segment. Now D, static integer D, it will store in, this is not initialized, it will store in BSS segment. Now static int E, it will store in the data segment because this is initialized. Now my question is why I gave this example. This was not in my part to show this example because I saw here some answers. They are telling that okay, we'll store in ROM. Okay, we'll store in ROM. And if we'll store in ROM, where we'll store it? Because whenever in embedded system, if you are writing any program in any microcontroller, they have one startup file. In startup file, it is clearly mentioned which variable, where it will store, with which address. What is the starting address, what is the end address. So, and always it will be there in RAM. So remember, whenever we are executing the program, we are storing into the RAM, and this is the memory architecture generally we follow. Generally, this is the memory architecture generally we follow. Now coming to our next topic. So, what all things are present in the microcontroller? What all modules are present in the microcontroller so that we are using embedded system or we are doing embedded system programming. Now, so you saw this is my microcontroller and you also got to know that what is microcontroller. So our main topic is coming to now microcontroller because we are using microcontroller for our embedded programming, for our embedded programming. Okay, yeah. So what is microcontroller? So we got to know that microcontroller is a device which will store the program and execute that program. It's a device which will store the program and execute that program. Now, what is that? How it is happening? So where it will store and how it is happening. So whenever we talk about microcontroller, first it will have some CPU. That CPU may be 8-bit or it may be 16-bit or it may be 32 bits. That CPU may be 8-bit, 16-bit, or it may be 32 bits microcontroller. Now the second part is, as I told, we have some memories. We have some memories. It have RAM, also it have ROM. Next, we have some peripherals present. We have some peripherals present, which is very important. We have some peripherals present. First peripheral is GPIO, General Purpose Input Output. Same way we have ADC. Same way we have timer. Same way we have counter. Same way we have interrupt. Same way we have some communications module. Same way we have some communications module. Like example is UART, example is I2C, example is SPI, example is CAN. So these are one communication modules. These are so many modules are there. So if you see, if you talk about microcontroller, so these are things are present. We have some CPU, we have some memories. Then in the peripherals, we have GPIO, we have ADC, we have timer, we have counter, we have interrupt. Again, TX RX is coming under UART I2C SPI CAN. Exactly, cache. So cache also there. In different kind of memory also there. Not about cache. So we have double EEPROM. We have different kind of memories are there. Generally we insert. Okay. So these are the basic I'm telling. But apart from that also there are so many things are there. Cache is there. Other things are there. And TXRX, of course, TXRX is there. So whatever you are talking about, UART, I2C, SPI, and CAN. So these are communication protocols where we have one transmitter, where we have one receiver. So these things are present. So inside the microcontroller. So I think we are going to, in the practical session, we are going to see about GPIO, we are going to see about some peripherals. Everything is not possible in in 2 days, 4 hours. So whatever possible, we are going to do it. Okay. Now in the first module, the last topic I'm not covering now, that is development workflow overview, how generally we start the work. That we'll do later once we'll start with the coding. Okay. Now, fine. So I think today also we'll start little bit practicals. So that what will happen. I can suggest some softwares you can download today night, and you can also do tomorrow some practical if you want. And today also whatever practicals will be, you can proceed for that, and tomorrow so that you can come with your ideas. That also we can do and demo here. Okay. So next thing is that we are going to discuss. We'll talk about microcontroller families. So we talked about microcontrollers. So we'll talk about microcontroller family. So there are so many type of microcontrollers are there in the world. Okay, very basic microcontroller is nothing but your 8051 family. In 8051 family, again there are so many controllers are there like AT89C51. 8089C52. Same way. There are so many microcontrollers are there. Again, there is one more family, AVR family. So in AVR family, again, there are so many controllers are there like ATmega 8, like ATmega 16. You are seeing Arduino board, right? What is there inside the Arduino board? Inside Arduino board, there is a controller that is ATmega 328P. So that is, this microcontroller is part of AVR family. Same way, you have one more family is there. Nowadays, in every industry they are using. In your mobile phone they are using, in your vehicle they are using, in your every devices, whatever they are doing, they are using. That is ARM family, ARM architectures. So again here, there are so many controllers are there. ARM7 is there, ARM9 is there, ARM Cortex is there. Again, so there are so many microcontroller families are there. Now my question is, whenever you are going to write the program, whenever you are going to design the system, according to your choice, you can choose the controller. According to your choice, you can choose the controller. And one more thing, also, whenever you are going to write the program, whenever also you are going to write the program, you can write the program in one single format. That how you are going to implement in a single format for every controller whenever you are going to write the program, that also we'll discuss. So this is, I'm getting something here. Yeah, peak controller also there again. So peak family series also there. If we'll talk about your STM series also there, STM microcontroller is there. So there are so many microcontroller families are there. So here I'm not going to take any very hi-fi controller so that I can finish on time, but I'll go through whatever demo also will do. I'll go through very basic microcontroller where we'll start from scratch. That is called bare metal coding. Two things we are going to discuss. Today we are going to discuss about bare metal coding. Tomorrow we are going to discuss about without bare metal coding. So do you know what is bare metal? Whatever keyword I'm telling, bare metal. So what is bare metal? Any idea? Bare metal programming. So we are going to start bare metal programming. So what is bare metal programming? Okay. So bare metal programming. So I'll give one small example. Are you using laptop? Everybody you are using laptop, right? Whenever you are using laptop, same time what you are doing, same time you are listening music, same time you are editing in your MS Word, same time also you are doing some other applications. Am I correct? Yes or no? We are doing multiple things at same time. We are doing multitasking. Exactly. We are doing multitasking. So in bare metal coding, multitasking is not possible. In bare metal coding, multitasking is not possible. So this keyword is bare metal coding. Here, multitasking is not possible. Okay, because all the bare metal coding will run under while one. This is one infinity loop. It will run under that. Generally, your whatever small devices you are seeing, or whatever small projects students are doing in college, all are part of bare metal coding. All are part of bare metal coding. And whenever you are talking about multitasking, that time you need to introduce operating system. You need to introduce operating system. You need to introduce operating system. So operating system part we are not going to touch today. So basically for embedded system, we generally use two kind of operating system which is very famous. One is RTOS, real-time operating system. One more is embedded Linux. That information I'll give tomorrow. What is RTOS and what is embedded Linux, how it is implemented in the microcontroller. So that is not our topic. Our topic today is bare metal coding. So we'll start with bare metal coding today. So how basically you will build any system. How basically you will build any system by using bare metal coding. Now, directly programming the hardware without OS, directly control of MC hardware. Okay, exactly. Then where it is used? Where I did not get these questions. Can you repeat again these questions? Anyone? Amanpreet, running software directly on the hardware. Exactly. So software will run directly on the hardware. Directly, I have not used any slides. Okay, so again, I just want to highlight here to one point. I was telling there are two kind of coding was there. One is bare metal coding. Bare metal coding. Here, directly you are running the program in hardware. Directly your program you are running in the hardware. Also, in the operating system also, directly you are running program in the hardware. In both the case, directly you are programming running on the hardware. But what operating system will do? It will just manage. So that topic I'll discuss tomorrow. Same thing. Your questions. Here also we are we are running the program in hardware. But what extra operating system is doing? That part we'll discuss tomorrow. That what is kernel, what is shell, how it is helping the operating system. That part we'll discuss tomorrow, not today. But today topic is bare metal coding, where we are directly running the program on the top of hardware. Okay. So we are going to start bare metal coding. So before going to start bare metal coding, I just wanted to tell also some steps. Okay. Now we are going to create one system. Now we are going to create one system. So before going to create one system, what all things is required? What all things is required? First is compile. What is tool chain? First is required thing is tool chain. Then it's required compilers. It should be cross compiler. It should be cross compiler. Then you require one build system. Then you require one build system which will build the file. Which required one build system. Then you require also one firmware architecture. We require one firmware architecture. And finally, you require what? Flashing process. Flashing process, that is, you may use any debugger, or you may use any bootloader. Okay, so these things first we should know. What is toolchain? What is cross compiler? What is build system? What is firmware architecture? What is flashing process? And what is debugger? Yeah, I'll share all the materials. I have the PDF. I'll share all the materials. Why I'm not using PDF? Simple, if I'll use any PDF or if I'll use any PPT, I think you will get bored. For that reason, I'm not using that. Directly, I'm going for live. So, what all things is required, I'll do it. But tomorrow, at the end of the sessions, you will get your complete material. Okay. So there it's clearly mentioned. So here it is, I can, if you will tell me what is embedded system, I'll talk about 2 days. If you'll tell me about embedded system, I'll talk about 2 days, but that is not really help you. My intention is that here, what is embedded system, and by using embedded system, how you will create one system, that is my main agenda. So that tomorrow you can say that, okay, this is embedded system, by using that, I can create anything. Or this is the FDP program where you are getting 4 hours. In 4 hours, I cannot give you the complete embedded system topic, but I can give you the path, how to start, where to start, and how to improve. That is my main agenda. So for that reason, I'm covering all the things. First, where I talked about what is embedded system. And also I introduce one more thing, why you are going to learn embedded system, because the scope is there. What is the scope of embedded system? Then we are discussing about embedded architecture, where you talked about what all things are there in embedded system. Microcontroller is there, your devices, whatever your peripherals are there, your what is that called? Your memories are there. We discussed that. And finally, once you got to know what all things are there, now then how will you utilize all the things? So you got to know what is microcontroller, you got to know what is memory, you got to know what is peripherals. Now, how to utilize that? Now that is my main agenda. So before to going to that, these are the second module where we'll cover about tool chain and development environment. Okay. I'm not going to discuss much here because whenever I'll do the practicals, there I'll explain what is toolchain, what is compiler, what is build system, what is firmware architecture, and what is flashing process. And I'll give the clear explanation there, what is debugger, what is bootloader, all these things. So I'll give a small example. I'll ask them small questions about this flashing process. So do you know how, suppose you are using one mobile phone, right? You are using one mobile phone, and whenever any new version of software is coming, any new version of software is coming in your Play Store, and it is telling that install the latest version of these things, Android, install the latest version of operating system. How you are installing? Will you installing or automatically it is taking care? You will just click the button installing, right? Apart from that, are you doing anything? Apart from that, are you doing anything? No. There, this bootloader is taking care. So all these things I'll tell whenever we are going for this process. Okay, whenever we are going for flashing process. So that time this bootloader is taking care. So we will discuss all these things. So in that time we'll discuss all these things. What is bootloader? What is flashing technology? So before going to that, I want to go for chapter number 3. Chapter number 2 directly I'll explain whenever we'll start the practicals. Chapter number 3, sorry, chapter number 2, I'll explain whenever I'll start the practicals. Before going to that, I'll come to chapter number 3. Your chapter number 3 is Embedded C Essential. Your chapter number 3 is Embedded C Essential. This is, I'll not take more time. Here in Embedded C Essential, I'll just tell the things in embedded system, what all things we generally use more in embedded C. Okay. First one is embedded C. The first one is very simple concept here. Range. Why I'm taking also this topic? Because this is also really important. So first one is your range. This is the first thing we are checking very much. Whenever we are writing any program, we'll check range. Why? Suppose I'll give one scenario. Okay, I'll give you one scenario. Suppose there is a sensor is there. This is my microcontroller and this is a sensor. Now what will happen? In this microcontroller, we are connecting the sensor. Now requirement is when this sensor value is 150, when this sensor value is more than 150, that time your system will crash. Whenever the sensor value is more than 150, now the sensor is calculating the value. Now when the sensor value is more than 150, that time your system will crash. This is my requirement. Okay, simple thing I'm telling. Some practical example I'm telling. Suppose this is the sensor value. This sensor is detecting some value, and whenever this value is more than 150, system will crash. Or a simple example I'll give. You have written one program for flight. Whenever the value will be more than 150, you should land your flight somewhere. Otherwise, your flight will crash. This is the requirement. Now, I'll write one very simple C program. Very simple C program. Very simple means very, very, very simple. Suppose I'll write one program. You need to tell me the answer. What is the answer? Void main. This is my program. Character A equal to 125. Okay. Now I write A equal to A plus 5. What is answer? If I'll print now, what answer you'll get here? Anyone? This is very simple questions. Anyone? Any other answer? I'm printing with percentile D. You will get exactly value. This is not required about ASCII. If I'll print with percentile C, then I'll get ASCII. Here I'm just adding 125 plus 5. What value will get? I think everybody is telling answer is 130. Okay. Everybody is telling answer 130. For that reason, I told in embedded system, range is very much important. If I run the program, you will not get answer as 130. You will not get answer as 130. What answer you will get? I'll see. I'll explain one thing. Then automatically you will get to know how it is calculated. Okay. So because that really we are doing in the industry. So I'll run this program. If I run the program, I'm getting minus 126 answer. You are telling 130. You are telling 130, but data type is already there. Data type is already there. So it depends on data type. It is fine, but data types also already I mentioned here. Clearly, I mentioned the data type. So answer is 1 minus 126. Will I explain? Can I take a 2 minutes to explain this, how it is happening, so that your things will clear from next time? Will I take 2 minutes from your side? If yes, I'll explain, please. Okay. So, yeah, whatever you're telling 8-bit sign, it's really correct. It's really correct. Only you need to remind your things. Okay. So what I told, this variable is sign. I told this variable I have written character a equal to 125. Okay. So basically this is nothing but sign character a equal to 125. By default, any variable is sign if nothing sign is mentioned. So the size of character is 1 byte. The size of character is 1 byte. 1 byte means it is 8 bits. 8 bits means always the value will be the range in the form of 2 to the power 8. Always the value will be range in the form of 2 to the power 8. If I'll calculate 2 to the power 8, what value you will get? You will get 256. You will get 256. And the next point is, it's a signed character. Signed means always the range will be, the value will be from negative to positive. Always the value will be from negative to positive. Now, that means your value will start from negative and it will go up to positive. Half of the value will be from negative side, half of the value will be in positive side. Now, that means 256, if I do it divide into 2, the answer is coming 128. That means if the value starts from negative, that will be 120 minus 128 to 127. Why 127? Because 0 also there in between that. So this is the range. So now if you put in this way, what will happen? It will start, your value will start from minus 128. Your value will start from minus 128 and it will go. Somewhere it will reach to 0. Somewhere it will reach to 50 and finally it will end with 127. Finally it will end with 127. So this is the last value. So now your question was, that means I have defined one character A and I'm telling A equal to A plus 5. In A, maximum you can hold value up to 127. Maximum you can hold value up to 127. So now this value is really coming 130, which you are telling that, okay, this value is coming 130. Now, but it is holding maximum up to 127. How many extra value you are getting? How many extra value you are getting? You are getting extra 3 values. You are getting extra 3 values. So it will work in this way. So this is the first value. This is the second value. This is the third value. First value is minus 128. Second value is minus 127. And third value is minus 126. In this way, it will again go. In this way, again, it will work. Once it will reach to 127, then again, it will start from the starting value, minus 128, minus 127, minus 126. For that reason, answer is minus 126. For that reason, every data type, character, integer, everything will follow in the same way. Okay? Everything will follow in the same way. For that reason, as I told, in embedded C essential, this is the first factor. This is the first factor which matters more. Which matters more. So first one is range. Second one is your storage class. What I explained. Which variable will store where. Third one is your bitwise operators. This is the main important role in this programming, embedded C programming. Fourth one is some memory concept like volatile keyword, like volatile keyword, like volatile keyword. Then there are also so many other memory concepts. There are also so many other memory concepts are there. Apart from this, in memory concept, we'll talk about your whatever memory I told, heap area, your text area, your stack area, your BSS area, your data area. So all these things are coming under that. Okay. And main thing, you are going to do register level coding. And finally, also some standards you are following. Whenever you are writing the code for industry, whenever you are writing the code for industry, that time we follow some standards like Misrashi standards. Misrashi standards. So some standards you are following. So in embedded C, these many topics are really important. Okay, these many topics are really important. So of course, these you can note it down. If you really want all these concepts, tell me tomorrow so that I can explain all the concept one by one if you get time. Or we can extend one more half an hour tomorrow if you want really this concept. Okay, this concept is really important for embedded system, where we'll not discuss about embedded C essential in detail here, just we'll discuss the outline. So this concept is required whenever we are going to write the program, whenever we'll start developing the project, developing the product. All these things are really important. Okay, telling something, please extend time. We can extend. Okay, I'll check with management. That is fine. Just give me 1 minute. Okay, sorry. Yeah, somebody what? Please, sir. No, it is not register actually. It is register. It is register level coding. Sorry, I'm wrong. This is register level coding. So your second one, REGISTR level coding. Okay. So that register level coding you are going to do. So we'll start now little bit today practicals. We'll start now today little bit practical so that tomorrow we'll do more practicals. So that tomorrow we'll do more practicals. At least today also I'll tell what all softwares you are going to install. If you are really interested to install the software, you can install tonight. And tomorrow we are going to do the more practicals with all the peripherals like timer, counter, ADC, serial communication. So we can do it, because if I talk so many theories, it will not really help me, or it will really not help you also. So we will start with a very basic controller. Okay. You don't think that, okay, why you are starting very basic microcontroller? Because first one is time constant. Second one is, if you are writing the code for very basic controller also, I'll give you the next framework, same structure you are going to apply in the advanced microcontroller. Everything is same, everything will be same. Okay, that difference also I'll show you. I'll write two programs, and there also I'll show the difference. Okay, so now we'll start our embedded software development, where your topic 2 also will get covered, because whatever things I told in topic 2, so that cross compiler, IDE, build systems, format structure, classing process, all these things will cover in the when we'll start our embedded system development process. So for starting your embedded system development process, embedded systems development. software development. Now, whenever we are going to start your embedded software development, the first thing that we are using the language embedded C, that is equivalent to C also. If you'll ask me the difference between C and embedded C, it's almost same, but in embedded C, we are doing B level coding. We are doing the code for registers. And also we are following some certain structure like memory concept, like volatile keywords. All these differences are there, but almost same. Then you are going to use one platform. We are going to use one platform that is Kill platform. That is Kill platform or Kill software. We are going to use Kill software. Second thing, we are going to use compiler. What compiler we are using? We are going to use Kill C51 compiler also. Then we are using one tool for simulation, as we don't have real hardware, right? You also don't have real hardware. I also don't have real hardware. But if I write the program, I need to I need to validate my software in some places that, okay, my software is correct and whatever system I develop, that is also correct. For that, we are using one software called Proteus. We are using one software called Proteus. Very 2 minutes I'll tell where from where you will get this Kill software. Okay. And your language, we are going to use embedded C language. That is the C language. Platform, we are using Kill software. From where you will get it. It's very simple. Just go to the official website of kill.com. Then from there, go to downloads. Go to product downloads. Then we are using very basic microcontroller 8051 devices. So this is the software. If you are using ARM controller, you need to download this one. If you are using this, you are download this one. But we are using 8051 devices, so you need to download this one. Please give all the informations here. Once you will give all the informations, first you will give, once you will give all the information, then you have to submit. Then this will come. If you click on this, automatically it will download the software and you can install it. That is the first software you can install very easily there. And the second software is Proteus. You can also get this software for free from different platforms. This is the software, Proteus software. If your image will come, this image will come. So this is the from different platforms. You can download that. The software name is Proteus software. The software name is Proteus software. So this is the Proteus design suite or Proteus. You can download any software. These are the two softwares you are going to use it. Now, before going to start the programming, I just want to give also the information what controller we are going to use. So we are going to use the microcontroller. We are going to use microcontroller. Name is 8089C51. This is the microcontroller name. So this is the 8051 microcontroller. In this microcontroller 8089C51. This is the microcontroller we are going to use. I'll just take this controller from here. 8089C51. So very simple thing. It's a very simple. It's a 8-bit microcontroller. It's a 8-bit microcontroller, and the microcontroller will look like this one because this is the product of Atmel company. This is the product of Atmel company, and the microcontroller is looking like this. Okay, you can see this is the device also. If you see where you will see one notch is there. Wherever you will see there is a notch, from that side your count will start 1, 2, 3, 4, like this. Your count will start. So second part is how this controller is. Okay, this is my microcontroller. So, okay. So this is my microcontroller. You can see here. So this is my microcontroller diagram. Means this is my microcontroller pin diagram. Okay. If you see here, how many? So these are one port. When you'll start with any microcontroller device implementation, whenever you are doing any project or whenever you are doing any product with any microcontroller, first you need to see what all things are present in this microcontroller. This is a very basic microcontroller where I can explain in very less time. So you can see this is port 0. Am I correct? Port 0. This is port 0. P0. P0 is known as port 0. So in port 0, how many pins are there? These are 8 pins are there. This is 8 pins there. Again, same way, we have port 1. Again, port 1 having how many pins are there? 8 pins. Instead, someone is telling something. Okay, this is port 1. This is 8 pins are there. Next, this is my port 2. Again, 8 pins are there. Eight pins are there. Again, this is my port 3. 8 pins are there. Eight pins are there. So total how many pins you are seeing? Total in this microcontroller, we have 40 pins. In this microcontroller, total we have 40 pins are there. Apart from 40 pins, now you are seeing port 0 8 pins, port 1 8 pins, port 2 8 pins, port 3 8 pins, total 32 pins we have, which is called GPIO, General Purpose Input Output Pins, which is called GPIO, General Purpose Input Output Pins. Why? The meaning is that if you want to connect any input device or any output device, if you want to connect any input device or any output device, then you can connect in these 32 pins. You can connect in these 32 pins. Okay. So for that, this is called GPIO pins. So we'll start today with GPIO programming. Tomorrow we'll go for peripherals, other peripherals programming, which is the little higher end, where we can discuss about time, or we can discuss about any concept like serial communications, any concept we can discuss there. So today we'll start with GPIO programming. So before going to start GPIO programming here in this microcontroller, I'll tell two things today. One, how generally whenever we write the code in the college days, how we are implementing, and whenever we are writing the code in the industry, how we are implementing. The two things I'll also show the difference today. And the process, everything is same, but little standardized process, how generally we follow, we'll write, that also we'll cover here. So now we have 4 ports. Wherever you want, you can connect. Now our main topic is, we'll start with GPIO programming. Okay. The first, very basic, I'll do 2 projects in GPIO programming. First, I'll take one small LED, I'll make it on. Then I'll take one input devices switch. When I'll press the switch, I can on LED, or you can run any DC motors. So the two projects we'll do. So simple project I'm going to do. For the first project, what I'll do, this is my microcontroller. I'm connecting one LEDs, and I want to connect this LED. I am connecting one LED, and I want to connect on the LED. I want to connect on the LED. This is my first project I just want to do. And I told I have 4 ports are there. I have connected in port to 0 number pin. Before going to start the programming, also 2 things you should know. So what you are using port 2. What is that? This is a register. This is a register. Now, as you are writing the program from scratch, If you are doing the programming, if you are doing the project in Arduino, if you are doing the project in Arduino, you are using the, you are not doing from scratch. We are not doing from scratch. What you are doing? We have the libraries, you are using that. And if you are doing any project by using Arduino, you can do the project, you can complete the project, but learning wise, zero. You will not get to know what exactly this is happening inside that. Now, whatever things we are doing now, we are doing from scratch and we are doing bare metal coding. So now, from scratch, we are doing it. Now, whenever I'm telling, I'm connecting, I'm using port 2. Now, you need to tell where port 2 is there, because whenever you are manufacturing the microcontroller, they don't know anything. It's a hardware. It's a hardware. So we need to tell where P2 is there. For that reason, what we are doing, we are using one keyword called SFR. Actually, the full form of SFR is Special Function Register. The full form of SFR is Special Function Registers. So, by using SFR, you can tell where P2 is present. Simple, I am telling SFR P2 some address. This is present in this address in my microcontroller. As it's a 8-bit microcontroller, you can see the address also in 8-bit format. Okay. So, suppose we are using port 2, you need to tell where it is present. Suppose tomorrow we are using port 3, again you need to tell SFR port 3 where it is present, because this is really required. Otherwise, whatever registers are there, where it is present, you need to first define it. Now the next point is, now again the next point is you are using port 2 0 number pin. Basically how it is there, how this register is there, this is my port 2. This is my port 2, and in this port 2 we have 8 pins, or you can say also this is one 8-bit register. Also you can say this is one 8-bit register. So anybody is telling something? What is 80 and what is 90? I'll explain. No, not worries. 80 and 90, these are address locations. Okay. So generally, whenever you can give the representation of address in any format. You can represent in any format. Okay. What is that 80 and 90? Okay. So simple. Your microcontroller is one 8-bit microcontroller. Your microcontroller is one 8-bit microcontroller. Now tell me, what is the minimum value in this 8-bit? Minimum value is 0. Maximum value is 256, right? Minimum value is 0, maximum value is 256. Simple. This is in decimal format. Whenever you convert into hexadecimal format, the minimum value is 0x00 and the maximum value is 0xFF. That means whatever registers you are assigning, that means whatever registers you are assigning, whatever registers you are assigning, 2 to the power 8 equal to 256. So whatever registers you are assigning, the register will be in this memory region. Suppose this is your memory region. So your memory region will start from 0. If you will write in the binary format, sorry, if you will write in the decimal format, it is 0. If you will write in the hexadecimal format, this is 0x00. From this, your memory region will start. And where is your memory region will finish? Because this is a 8-bit controller. Your maximum memory region is 255. Sorry, yeah. The minimum value is 0. 8 to the power 8 is 256, but the range is from 0 to 255. Yes, you are correct. Sorry, I'm sorry. So this value is 0 to 255. 2 to the power 8 equal to 256, but it will start from 0 to the 255. So the maximum value will finish with 255. And if we will represent in hexadecimal, this is 0xFF. So I'm telling, in my memory, somewhere in this 0x80 address, suppose here this is my 0x80 address, 0x80 address, here P2 is present. Now I'm keeping here P2. I'm keeping here P3. Understood now? What is that 80 and 90? In between some address, I'm putting P2 is present here, P3 is present here. Whatever your registers are there in 8051 microcontroller, whatever registers are there, I'm keeping in between that. I hope you're clear with this. Okay. So it will start with 0x00 and where it is there. So memory is there. So now P2 register, I'm telling it is present in 0x80 address. Now in this P2 register, if you will see, now if in P2 register, how to we know the address, sir? Yes. How to know the address, sir? Yes. I'm just giving this example because you are writing the code from scratch. Now if you are coming to your questions, now suppose you are making one product, right, in and out of the product. I'll give one small example. Suppose you are it is your interest that as for you are doing your teaching professions. Apart from that, also your interest is that you are making one cake and you are selling into people. This is the second interest. Suppose now you are making one cake, and in that making there are 7 layers flavors are there. Now you know in which layer which flavor you are giving. Am I correct? You know in which layer which flavor you are giving. Same way, whenever any vendor is manufacturing the microcontroller, whenever any vendor, suppose Atmel is manufacturing this microcontroller, so Atmel already you will give the information that this register is present in this address. This register is present in this address. So already Atmel will give this information. This is called data sheet. So whenever they will release any product, they will release the product with the data sheet and they will give all the informations which register is present in which address. Clear my point? I hope clear. Yeah. So now next point, I'm coming to again here, coming back here P2. So this is my P2 zeroth number bit. This is 1 number bit. This is 2 number bit. This is 3 number bit or 3 number pin also you can say. This is 4 number bit or 4 number pin. This is 5th number bit or 5th number pin. This is 6 number bit or 6 number pin. This is 7th number bit or 7 number pin. So again, so you got to know how you are going to interpret P2. So P2 by using SFR keyword, you can give it. You can give it. Now, there is one more keyword is present, that is S bit. By using S bit, you need to tell which pin you are using, which bit you are using. Now, there are 8 pins, there are 8 bits, but where you have used, which bit you have used, which pin you have used, that also you need to tell to the compiler. That also you need to specify. So in which bit it is used. Now I'm telling it is used in P2 underscore 0. Now we are telling that it is used in P2 underscore 0. Now that also you need to define. The format is, how the format, you will write S bit P2 underscore 0 equal to P2 caps operator 0. In this format, you can do it. In this format, you can do it. Suppose you are using bit number 5, then you can do S bit P2 caps operator 5. You can give P2 caps operator 5. This is only specific to whatever I have written. This is only specific to 8051 controller. This logic is only specific to 8051 controller. This S bit keyword is only specific to 8051 controller. I don't want that one. That you are I was doing in college days. Now, whenever we are writing the code for industry, we need to make it specific so that if tomorrow you are going to use AVR microcontroller, if tomorrow you are going to use ARM microcontroller, how you will write the code. But first, we'll write the code in this format. Then tomorrow, we'll start with the program in a standardized way. How we'll write the program in a standardized way, that will start tomorrow. So today, we'll start the program. We'll do one practical, but tomorrow again same product, same practical. We'll do in a standardized way, generally how people will follow in the industry. Okay, so everybody clear why we are using SFR, why we are using SBIT. Now coming to your project again. So this is my project. What is my project? I have one controller. I have one controller In this controller, I am connecting one LED. My requirement is I need to on the LED. My requirement is I need to on the LED. Okay, again. So this microcontroller name is AE89C51. 88 This is my microcontroller name. Okay. Now I'm connecting one LED. Where I've connected? I'm connected in P2 underscore 0. I'm connected in P2 underscore 0. Okay. Now I want to on the LED. I want to on the LED. So how will do it? Okay. So maximum supply you can give to this microcontroller is 5 volt because this is a DC device. This is a DC device. So maximum we can give 5 volt. And how your LED will on? If you will give supply 5 volt here, your LED will on. I knew again your questions. If I'll give 5 volt also to LED, your LED will burn. Yes, of course, your LED will burn. So what I'm doing here, I'm not using directly. You will give 5 volt, your LED will on. That also we can do it. But your question is, if you will give 5 volt, then your LED will not, LED will burn. So in this case, if that is the scenario, you need to change in hardware. You need to connect one resistor here so that it will drop the voltage. As for the Ohm's law, V equal to IR. You can calculate, and whatever resistance value will come, you can do it. So now, so I told that if you'll give 5 volt, your LED will on. So in the software, if I'll give 1, it will, in the hardware, it will give 5 volt. In the software, if I'll give 0, in the hardware, it will give 0 volt. Simple. This is the concept we are using, high and low. If I'm giving 1, it will give 5 volt. If you are giving 0, it will give 0 volt. Now, we'll start writing the program. How we are writing the program? We'll start writing the program. Okay. So now we'll start with some header file. I'll not write here. So generally, any program will start with header file. Here, why I'm writing this header file, I'll show you today only. Has include register 51.h. This is the header file. Then I told you need to tell where you are using P2. So you will do SFR P2 equal to 0x80, some address, what address you are doing. Then you are using S bit because you are going to use P2 underscore 0, P2 underscore 0 equal to P2 caps operator 0. Then void main. In C program, C program will start from void main. So in C program I'm writing. So if I'm writing this value equal, what is the value? P2 underscore 0. If I write P2 underscore 0 equal to 1, that means LED on. That means LED on. If I'm writing P2 underscore 1, that means LED is on. So LED will on. So this program will run how many times? This program will run how many times? This program will run for one time. If you want to run your LED for infinity times, that is a loop called while one. That is a loop called while one. So you will write the program under while one. For that reason, in the bare metal programming, all the code is under while one. All the code is under while one, so that it will run for infinity times. This is the first concept in bare metal. In bare metal, whatever program you'll write in one infinity loop. So while one is the best option for infinity loop. For that reason, whatever program we'll write under while one. Clear, everybody? Yes. What is the meaning of SBIT P2? This is the format generally we use. This is the generally format we use. Okay. So that also I'll remove tomorrow. So don't worry. So now what we'll do, this is the program. So what I'll do, I'll open my software. Once you will install, you will get this one. This is the software, kill software we are going to open. Once you open the software, this is the tool you are getting it. Okay. I'm creating one folder. I'm creating one folder here. Okay. So I'll create one. Okay, so how to proceed for that? Guys, can I take another? It is free software. It's free software, and also you will download from their own website. It's a free software, and also you'll download from own website. This is the generally we use the platform. Can I take your 5 minutes? Already time is there 8 o'clock. Can I take another 5 minutes? Yes. Okay, fine. So why I'm taking another 5 minutes? If today I'll finish one project, right? Tomorrow, anytime you can give your time and you can finish so that tomorrow we can do something more. This is the very basic. So tomorrow we can do serial communication or something, we can do it. So now, what is the next step you will do here? What is the next step you will do? So you will go to project. You will go to project here. See, this step is very important. Why I'm telling, and whatever so many questions also will clarify in your mind. Project. Then I'm making new microvision project. Okay. So I'm going to here where I have given. So this is my FDP. Here I'm creating one folder. I can give LED on. So in that I'm saving my LED on. So then it is asking for the controller. So if your controller is coming directly, this is fine. If your controller is not coming directly, what you will do? Select these options. Select this option. Search your controller 889C51. This is your microcontroller, which is the product of microchip 889C51. Okay. This is very important step. It is telling copy start of A51 to project folder and add file to project. You need to add this file. Yes. Why? Because we are doing the program for 8051 microcontroller. And in the startup file, it is clearly mentioned. If you will start a file, you will not understand. But in the startup file, it is divided in the regions. I told, right, there are 5 memory segments are there. Heap segment, stack segment, BSS segment, data text segment. So there are 5 segments are there. All the 5 segments you will see here. Which segment will start from which location, which segment will finish in which location. This segment will start from which address, this segment will start from all this address. So all this information will get here. Apart from this also, startup file will do so many things. I'll explain tomorrow. Okay. Now let's focus on the project. Now I'll go for file number, new file. New file that I'll save as here as main.c. I'll save as main.c. Now I'll write the program. What program? As include register 51.h. Then you are writing SFR P2 equal to 0x80. Then you are writing SBIT P2 caps operator 0 equal to, P2 underscore. I'm just giving any name. You can give any name. P2 underscore 0, P2 caps operator 0. I'll show also that is for admin. Then inside that, I'll give while 1. Inside that, I'll give while 1. Then P2 underscore 0 equal to 1. That means your LED is on. That means your LED is on. Okay. In place of P2 underscore 0, you can write anything. Suppose I can write LED. So here also you can write LED. That means LED is connected in port to 0 number pin. Port to 0 number pin. LED is connected port to 0 number pin. I'll clarify your doubts. Give me 1 minute. I'll finish it. Then next 5 minutes, I'll clarify your doubts. So LED equal to 1. So then you can save it. You can save it. So this is the setting you need to do. Here you need to do the setting. Your frequency for this controller, you are using some frequency 11.0592. If you want, you can take the screenshot of this page also for your reference. You are using 11.0592. And the second options, whatever program you are writing, that program you will do use on ONCPROM. That you are putting in ONCPROM. ROM. Okay. You are creating the hex file and you will store in some folder. Fine. Why you are creating X file? I'll tell tomorrow. Don't worry. Again, this process will continue tomorrow also with the better way, within standardized way. So here also, we are not doing any code optimizations. Okay. We are also setting your include path. If you have any header file, then you can take from this folder. For that reason, we are doing it. Now, this is the done. This is the compilation button. If you will compile it, it will not work because this C file you have written, right? You need to take to your project. Now this is there in a local. Now you need to take to your project. So I need to add this file. I need to add this main.c file. Add it. Then this is my main file. Okay. Now if we'll click on this, you can see here, you have some errors. Some errors you are getting. P2, define, don't define it, remove it. Why I'll remove, I'll also tell you. Now you do it here. 0 errors, 0 warnings. Now you have created, you have successfully built your project. Tomorrow I'll show the output. Today I'm showing successfully you have done it. Now if you see here, your register 51.h is there. So this information already it is there. You can see all the registers. All these registers are from 8051 register controller. All these registers are from 8051 controller. And all the registers, they already assign the address. Who? Atmail company. They have manufactured the controller. They have manufactured the controller and all the address they have given you. So for that reason, from starting of the program, I'm writing this header file so that I'll get my definition of P2. For that reason, I'm writing this 51.s. Clear? Yes, guys. I think we'll continue from tomorrow.
So I cannot see any more questions. So thank you all for such an engaging questions and discussions. The level of interaction today, I believe it reflects the growing interest in embedded systems and hands-on development practices. So as we conclude day one of this FDP, I hope today's session have helped you build a strong foundation in embedded systems, understand how development environments and functions in practice. Also, from an academic perspective, these concepts are extremely important in strengthening your conceptual understanding, problem solving ability, as well as modern tool usage. So at the same time, they also contribute towards your enhancing hands-on learning, outcome-based education, which are actually the key focus areas for NAC and NBA frameworks. So moving forward in the next session, as I said, we'll go into more into understanding the Proteus software peripheral programming, the hardware software interaction debugging, and testing techniques. So these are the areas where students often face challenges and where faculty intervention can create a significant impact. So once again, thank you to Saswat sir for his valuable time and insightful session. And thank you to all the participants for your active involvement and enthusiasm. So before I end this session today, would like to have a quick review on what we do as SkySkill Academy or SkySkill Labs, what we call. I hope I can see, as I mentioned very early during the session, I can see a lot of familiar faces. So you might be aware of what we are doing. For those who are not aware, as I mentioned, SkySkill Academy, it's a skill tech platform. We provide skill program for students for engineering background professionals, for industry professionals as well. So we have a lot of courses uh, for product designing, for embedded systems, for electric vehicle, automotive technicians, even into CS and IT. So this is a website which focuses on more on the training aspect of it. While we have another website known as SkySkill Labs, it's a different vertical by SkySkill Academy, which set up lab or center of excellences in the within this infrastructure. So we cash the attention towards giving more hands-on understanding or hands-on learning for the students. So we do offer labs in embedded systems, IoT, robotics, EV labs, solar labs. So if you have any questions related to this, I'll drop all the links of our website in the WhatsApp group as well. If you want to come back with any queries, if you have similar requirements, we can discuss this forward. So thank you all for such an engaging participation during this particular session. Wishing you all a pleasant evening. We look forward to your continued participation in the upcoming session or day two session after. Thank you so much.